In this video, we're going to begin building a user interface for the simulation. To start, we'll add a simple drop-down menu that allows the user to select which movement state is active on all of the citizens. Let's create an empty game object in our scene called Interface. We'll move it right above the World object. We'll also reset the transform so that it sits at the origin. Now let's create a new canvas object underneath our interface object. Under the canvas, we'll create another empty game object called HUD, which is a common abbreviation for Heads-Up Display. You can press the F key in order to focus the Unity editor onto the canvas while it is selected. We're now going to use the Anchor Presets window under the HUD's Rect Transform component to position it within the canvas. If you hold both Shift and Alt, then you'll be able to set the anchor, pivot, and position for the object all at the same time. Choose the option in the lower right that stretches them all out to fill their parent's object. Now, our HUD will fill the entire canvas. We're now going to create a UI panel underneath our HUD object. This is basically just a quick way to create a window background. It attaches a default material and an image component to a new object. Let's resize the panel so that it fits into the lower right corner of our canvas. We're going to use the Anchor Presets window to set the anchor and the pivot to the lower right of the HUD. We are not holding Alt to set the position this time. Let's rename this panel to Lower Right. Now we're going to create an empty game object underneath our panel and we'll name it Movement Rules. Let's manually resize the Rect Transform for this object so that it sits near the top left corner of our panel. We're also going to set the anchor and the pivot to the top left of the panel. Now let's add a TextMesh Pro text component underneath the Movement Rules object. This will prompt us to import the TextMesh Pro essentials. Go ahead and click the button and they will automatically be added to your project. Let's change the text of the component to read Movement Rules. We'll change the font size to 12 and the vertex color of the text to solid black. Then resize the text component and move it near the upper left of the Movement Rules object. We can also use the Anchor presets to set the anchor and the pivot to the upper left. Let's select our lower right panel in the scene so that we can get rid of the transparency it has by default. Simply click on the color field of the image component and you will get access to a color picker where you can slide the alpha channel all the way up to its maximum value. Let's now rename the text component to Label. Then we can add a TextMesh Pro drop-down component underneath the Movement Rules object. Manually resize the component until it is nicely aligned underneath the label. Let's also set the anchor and the pivot to the upper left, and then we can remove all of its options because we'll be adding them in our script. Let's now run the application just to get a look at how the UI appears within our application, in case you want to make any changes. Now we also have to update the event system that was created when we introduced the UI canvas. This is the system that will respond to input interactions with the UI. It's currently giving us an error because we're using the new input system and the event system defaults to the old input system manager. Luckily, Unity has added a convenient button that will replace the old system for us automatically. We're also going to move the event system so that it sits underneath our interface game object. This will keep all of the UI components nicely organized together. We can now introduce the script that will control our UI. Let's call this script Interface. We will place the script under the Components folder because it will be a mono-behavior component that is attached to a game object in our scene. Let's add the script to our root namespace like we always do, and we can also clear out the Unity callback methods. Let's introduce the awake method to get started. We're going to want a reference to the TextMesh Pro dropdown object in our scene. Let's define a private variable called rules dropdown and then make sure you import the TextMesh Pro namespace. We can get a reference to this object using the static find method we've used many times before. We're also going to qualify the name of this object with its parent's name to make it more specific. The find method could end up giving you the wrong object if you have more than one object in your scene called Dropdown eventually. We will now define a list of strings that we can use to set the dropdown options that we removed earlier. To populate this list, we're simply going to call the toString method on each of our citizen movement state type values. Now we can use the addOptions method in the dropdown class to supply these options. Let's attach the interface script to our interface game object and then run the application to make sure the options are being set correctly. As you can see, we can now choose each of the movement states from the dropdown. The next step is to connect some logic to this selection. We're now going to define a Unity action which will serve as the response to the event that is fired when a new option is chosen on our dropdown. This is very similar to the event handlers we have defined in the past. In fact, there is also a C# event handler called action. We are simply using the Unity version of an action because our dropdown is a Unity component. An action is an event handler that passes a single argument along with the event. Before, we defined an event args class that would allow us to define any number of custom arguments for our event handler. An action is essentially a shorthand for this process that takes one argument of a specified type. In our case, this argument will be an int, which represents the position value that was chosen on our dropdown. The next part may be a little confusing at first, because we're going to deal with two events. The first event happens when a new value is chosen on our dropdown. This will trigger our Unity action response. We will subscribe to this action with a private method in this component called onRuleChange. The second event will then be fired by this response method, and it will inform the entity system that a new rule has been chosen. We are basically chaining these two events together. First, the dropdown fires an event which is responded to within this script through our Unity action. Second, the response method will then fire an event handler event that the entity system will subscribe to, which will actually update the movement state of our citizens. This is definitely a bit complicated, but it should make more sense once you see it working. We are now going to define an event args class for the event which will be fired by this method. Let's create a script called onUpdateCitizenMovementStateArgs. This will be exactly like our other event args classes. It will contain a single reference to the new citizen movement state type that was just chosen. Make sure your class inherits from the event args in the system namespace. Now let's return to the interface script and set up the event handler for this new event. The first thing we'll do is create a new instance of our event args class so that we can pass it along when we trigger the event. Next, we need to convert the integer position that was chosen in the dropdown into a citizen movement state type object. We purposely listed the rules in the same order they exist in our enum. This means we can cast the position value directly to a citizen movement state type, because enum values are associated with their position in the enum by default. The next thing we'll do is subscribe the onRuleChange method to our Unity action. We do this in exactly the same way that we subscribe to our event handlers. We use the += operator to add the method to the call list of the action. Finally, to connect the action to our dropdown, we need to add it as a listener to the dropdown's onValueChanged Unity event. This is similar to how we called invoke to fire the events associated with our event handlers. In this case, the dropdown component will listen for the selection event and then invoke the event as a response. Let's pause here and test to make sure the first event is being fired correctly. We will log the event args in the response method to test this. As you can see, we are getting the event args logged to the console whenever we make a selection on the dropdown. We can see this even more clearly by logging just the movement state type to the console. Now we only get the name of the type showing up in the console. Let's delete this debug statement, and now we're going to set up the response method to our second event in the chain. This method will be defined within the entity system, because that is the system that has control over the movement states of the citizens. We will now define a method in our citizen class called setMovementState that allows us to assign a movement state to each citizen. It will take a citizen movement state type as an argument and then use this to look up and assign the correct movement state. Now let's create a method in the entity system that can update all of the citizens together. This method will have the usual event handler signatures so that we can use it to subscribe to the second event we are just about to define in our interface script. We will call this method updateMovementStates. In the method, we will simply loop through all of the citizens in the citizen list and then call the setMovementState method on each of them using the type that will be passed along in the event args. Now we need to define the event handler that will actually fire when we want to update the movement states. This event handler will be defined in our interface script, because that is where we will fire it from. We will call it onUpdateMovementState. Remember, you need to import the system namespace to get access to these basic event types. Now we will actually chain our two events together. The onRuleChange method will be called in response to the event that occurs when a new value on the dropdown is chosen. Then inside of this method, we will invoke the event handler we just defined in order to inform the entity system that we want to update the citizens' movement states. Finally, we need to return to the entity system so that we can subscribe our response method to this new event handler. In setup events, we'll subscribe to the event, and then in the quit method, we will unsubscribe. Now, our chain of events should be complete. The onRuleChange method will be called when a new value is chosen on the dropdown, and then the updateMovementStates method in the entity system will be called when we fire the onUpdateMovementState event. Let's run the application to see this in action. You can see the citizens begin in the idle state. Now let's choose the wander state from the dropdown. They all begin wandering after a random cooldown exactly like we wanted. And if we choose the idle again, then they will all return to their idle state after their current cooldown is complete. This completes the basic user interface we wanted to add. This also completes the base series for the Moonmist Hollow project. In future videos, we will be expanding on all of these core concepts to add more behaviors to the citizens. Please feel free to comment any suggestions for where you'd like the project to go from here. This is intended as a community project. The code and the application will also be freely available for you to try your own ideas. The project up to this point in the development will be available under the base GitHub repo, and from here the rest of the development will be available in the main repo for the project. So if you ever want to come back to this point to test things out or understand something, you can always come back to the base repo.